Setting the bias on Zener diodes is a really important thing. And you may be used to biasing Zeners for 12 or 15 volts. But once we get up to the high voltage that we need for our high voltage power supply, and I'm talking about 60 volt, 80 volt, 90 volt Zeners, you have to be more careful and check the data sheet carefully to see what the ideal bias current is for the Zener. You'll find that the high voltage diodes need much less current. It's very easy to over dissipate a Zener at 82 volts if you're not careful. So I've selected a resistor. This resistor is the bias resistor. You can see it's a 27K resistor. It's working against two Motorola 1-watt Zeners, each of them 82 volts. Let's take a look and see if this particular resistor, the 27K, will be adequate to bias the device to no more than 3 milliamps. I'd like to operate between 1 and 3 milliamps ideally. Remember, the voltage goes down on the input as you have heavier load. It's unregulated on the input, and it's really going to take the voltage down on the input of the regulator as you draw more and more current. Let's go up. Okay, I don't expect to see any current till we get up around 130, 140 volts. There's a little bit of leakage at 100 volts. Let's keep going. Okay, we're hitting the Zener knee. 82 and 82, right? 160, that's correct voltage. Let's go all the way up. Okay, all the way up unloaded. We know we're around 225 or 230 volts. We've got 2.3 milliamps showing. That's excellent. Now let's come down until it goes out of regulation. We'll consider that a half a volt. Around there. Okay. Let's check the voltage on the input of the stack. 197. That's ideal. We know that 200 volts is the 100 milliamp drop on the transformer. So we now have a good resistor to bias the Zener. Looks like the 27K resistor is absolutely perfect for our application.